June 2012 Core 4 question 5. I think most people know how to start these parametric ones. They start by differentiating them both. And so the first thing we've got here is that dx by d theta, cos goes to minus sine, doesn't it? Minus sine theta, and we've got a 2 in front of it. Dy by d theta, the sine goes to cos. Cos of what? Cos of the same thing, the 2 theta. There's already a 3 outside, but I'm going to times by the 2. So I'm getting a 6 out here. So dy by dx is equal to dy by d theta times this one upside down. So I'm getting 6 cos theta, cos 2 theta, divided by minus 2 sine theta. It's not in the format we wanted, so we're going to need to think about what have we got that's the same as the cos 2 theta, and you need to remember these ones here. Cos 2 theta is the same as 1 minus 2 sine squared thetas, and I'm dividing that by this. What have I got? 6 divided by minus 2 is minus 3. I've got minus 3, 1 over sine theta, minus 3 over sine theta, right like that for now. Minus, so I've then got plus 12 over 2, so that's 6. And we've got sine squared over sine, which just gives us sine. So my final answer here is I've got 6 sine thetas minus 3. Sine theta on the bottom, of course, is a cosec theta, just like you wanted over here. 6 sine theta minus 3 cosec theta. I did do an extra couple of lines of working there to make it clearer. Find the gradient of the normal to the curve when theta equals pi over 6. So let's stick theta equals pi over 6 into those two values there. And when we stick theta equals pi over 6 to those two values there, we get 3, take away 6, which is minus 3. Did it ask for the gradient of the tangent? No, it asked for the gradient of the normal. So we need to flip it upside down and make it negative. And there we're going to get our third. This one's nice though. This is the interesting bit. Lots and lots of different ways of doing it. What I did is I noticed we were looking at y squared, so I started by taking this y squared here. Y is equal to 3 sine 2 thetas, and I used that trig formula for the sine 2 thetas first as well. That this is the same as 2 sine theta cos theta. So when we square that, I'm going to get 3 times 2 is 6, 6 squared is 36. Sine squared theta, cos squared theta. That's a nice start. We actually know what cos theta is. It's from here. Cos theta is going to equal to x over 2. But we're going to need to know what sine theta is as well. And whenever we've got a cos theta, we can get to a sine theta by using the good old 1 minus cos squared theta square rooted. As we don't need to sort of square root it because we actually want a sine squared, all I'm going to do is I'm going to go for 1 minus this thing squared, and that's what the sine theta would be. Sorry, it's making a mess. Let's put them in. 36. Sine squared theta is that thing there. Cos squared theta is this one over here squared. Now, all I've got to do now is just tidy up these numbers to make this look a bit better. They actually want us to have a 4 here, so I'm going to have to times that one by 4. I've got 4 minus x squared, but we're going to need it to be a quarter of it. We need to times this by 36, and we also need to times this by x squared over 4. So when we finished, we're going to get 36 over 4 and another 4. So I think that's 9 over 4. We've got our 4 minus x squareds, and we've got another x squared there. And that's just a bit backwards, but it's in the format that we were being asked to get it. Y squared equals that.